particularly in the last, say, 30 years, where we started to get information on gene sequences and protein sequences. So in that time period, beginning in the 1980s, say, or late 1970s, it became possible to look at the complexity of molecules that function inside cells, genes that encode proteins, and to start to ask whether these informational molecules are tolerant of changes to their sequence, and if they are, how tolerant, and if they aren't very tolerant, how much information is contained in one of these things. It's taken many years and many people looking at these things to try to put numbers on that, but those numbers have come out in recent years. I've put a number on the fraction of possible protein sequences that can fold and function the way they have to inside cells, and it turns out to be an extraordinarily small fraction, 1 in 100 trillion, 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 which is not an easy target to hit. Those numbers could not have been, although I think if you go all the way back, when people look at living things, they would say that looks like it's been engineered, that looks like it's been made. It's only relatively recently that we could put numbers on probabilities, so that has changed the argument, I think.
It might be good just to piggyback on Doug's answer first, because the trend line in modern science, first in cosmology in the early 20th century, then in physics in the 1960s and 70s, and then in biology from the 50s, 60s, 70s, 80s, right up to the present, I think has been one in which more and more evidence is coming to light that points to a mind first rather than a matter first view of reality. In cosmology, you had the discovery that the universe has a definite beginning. In physics, the discovery that from the beginning, the physical laws and constants of physics have been finely tuned to allow for the possibility of life. And then in biology, in the area that Doug has done so much research, you have the discovery of a molecule that contains digital code, which is necessary for the production of all these proteins and protein machines. So we have nanomachinery, we have information processing technology inside cells, all on a miniaturized scale. It's an exquisite level of engineering design on display, and I think it really has put the issue of intelligent design, as opposed to just the Darwinian idea of apparent or the design or the illusion of design, back on the table. So the science, I think, has been trending away from the strict materialist view of the 19th century to a view that I think really needs to be open to the idea of agency or intelligence as being behind what we're seeing in the physical world.
Just to say that when you look at living things in particular superficially, you may not perceive just how sophisticated they are. And I think the natural world is one in which the deeper you look at cells, the more you find, as Steve indicated, levels of sophisticated coding and engineering that someone can spend their entire life solving.
So the 2004 JMB paper that I had published put a number on the rarity of functional protein sequences, and that number was that scary number. There hasn't been, so far as I'm aware, there hasn't been in the literature a response that said, no, that's not correct. And it would be hard to do because there was other literature that was pointing to that scary sort of number anyway. So I really confirmed something more rigorously that was already there. There are people, though, on blogs who will say, it's not that hard, you can get a functional protein, they're 1 in 30 or something like that. You won't get serious people who work in the field that say that, because it's a silly thing to say, and I can't respond to all the blog people. On the A to B transitions, interestingly, we have combed the literature. I should say, before Ann and I started working on the A to B, we were very open to the possibility that it would actually work. And in fact, we thought if we can get this to work, it'd be a really cool paper, because we show how long it would take in the wild, but we did it in the lab. We found that it wouldn't work. We couldn't get it to work, and we found that the change is so complicated that it would never happen in the wild. Nor could we find any convincing case in the literature of an A to B that would work, other than an A that already does B to a small extent, and that we didn't want to look at that case. So those cases do work. So we have an absence of any literature that confirms something that's thought to be a universal explanation for how you get protein diversity, which is a severe problem. We anticipated a complaint, and we thought we staved it off in the paper that describes this. The complaint that we anticipated was someone will say, when we show this A cannot evolve the function of this B in even billions of years, someone will say, no one said that that was the source of the B that you're looking at. The B came from some other prior source. And so in our discussion, we said, or even in the introduction, we said, we're not looking at historical transitions here. We're asking the more general question, can enzymes acquire new functions under selective pressure to acquire new functions? And if they can't, or if in an ideal case, a very favorable case, we can show that it can't happen, then we've undercut the whole that whole explanatory framework, and that's what we think we have. What have they said in response? They have said that A, you picked the wrong system. That A did not evolve into that B, and furthermore, by looking at modern enzymes, you're looking at things that are locked in. They're so perfected by natural selection that they can't evolve anymore. So, and we thought that's a remarkable change of tactic, because it's effectively saying evolution does not work. They're conceding that in the present tense, evolution does not work, but claiming that it did work on some special things that nobody can find. And if we tried to find them and they didn't work, they'd say you didn't find the right thing. So it really isolates the theory from any sort of testing at all, which we think shows that it's become a desperate theory.